see explosions all the time. And during my career as an engineer, I've certainly made a few. But actually understanding them and controlling all that power, that's a whole different story. And sometimes quite a surprising one. It's a story that starts with the accidents of the medieval alchemists.
Don't try this at home.
Whoa! But eventually leads us to a fundamental understanding of the forces of nature. Forces that we've mastered for good or evil. Explosives revolutionised battlefields, industry, and engineering. To uncover the story, I'll be reading the words of medieval scholars, going deep underground through ancient Cornish mines.
That looks like a lot of gunpowder to me.
And making some of the most dangerous substances ever known.
It mustn't go above 18 degrees centigrade.
It's a journey that will take us right to the centre of matter. Is that a split atom?
Oh, yes.
Wow! And the power it can unleash. This is the story of how we learnt to harness the forces that shook the world. The very first record we have of people using explosions comes from a Chinese document, which could date from as far back as 2 centuries BC. It describes how travellers in the mountain wilderness of the West were threatened by shape-shifting creatures of the night. To scare away these creatures, they would lay lengths of bamboo on their campfires. The very first Chinese firecrackers. The hissing noise we hear is moisture in the bamboo turning to steam. But bamboo has a special structure to it. It grows in sealed compartments. Now, when the moisture in these sealed compartments starts turning to steam, pressure builds up inside here. It can't go anywhere. Water, when it turns to steam, wants to expand hundreds of times, but there isn't room for it to do that, so pressure builds up. Eventually, the structure of the bamboo breaks down, it explodes, scaring away shape-shifting creatures of the night. Using simple, natural explosions like this was the first step of mankind's journey to harness explosive power, starting to understand the process in order to control it. It's easy enough to create an explosion. Any explosion is simply the moment when gas tries to expand suddenly. Oh! And when that suddenly expanding air crashed into the air around it, it created a pressure wave that then moves through the surroundings. The sudden change in pressure forced a cloud of water droplets out of the air. These allow us to see the wave. The faster the gas is trying to expand, the more powerful the explosion. And when that pressure wave hits your ear, you hear it as a bang. An explosion relies on a lot of gas trying to expand. Heat can make this happen, because heat, of course, makes things expand. Introducing more gas can do the same thing. But mankind discovered a way to create both heat and gas by reacting chemicals together. And this was the start of our journey to really master explosive power. In Europe, chemical explosions were unknown until the medieval period. And the first time people came across them, they were a bit shocked. I've come to the Bodleian Library in Oxford to see a manuscript that describes one of these early... It's one of the few copies of a book written in 1267 by the medieval scholar Roger Bacon, who split his time between Oxford and Paris universities. Now, this particular passage that starts et experimentum describes his knowledge of man-made explosives at the time. There is a children's toy, something no bigger than one's thumb, made in many parts of the world, that is an example of how something can assault the senses with sound and fire. It is no more than a bit of parchment which contains a powder combining the violence of that salt, called saltpeter, together with sulphur and willow charcoal. But the bursting of this small thing assaults the ear with a noise that exceeds the roar of thunder, and a flash brighter than the most brilliant lightning. Now, I suspect he may have been exaggerating slightly, but this was the first time that anyone in Europe had come across man-made explosives. Now, Roger Bacon was a Franciscan friar, and the church at that time had envoys all over the world. It seems likely that one of those envoys must have posted a package back to him containing these children's toys. The big question is, though, where exactly did that package come from? In the Middle Ages, the most technologically advanced region of the world was China. A printed book dating from before the Battle of Hastings indicates that the Chinese were already deploying explosives of a similar sort on the battlefield.
What we have here is a Chinese military manual, first printed in 1044, and in it we find a recipe for a thing called the fire mixture, or the fire chemical, which contains the principal 3 ingredients in Roger Bacon's recipe of 200 years later. We start off with, here we have these 2 things here. They're both forms of what we now call sulphur.
Right.
Followed by various forms of organic matter like pounded dried roots and twigs that produce the carbon. Followed by saltpeter, the next one, yenxiao. The saltpeter is something you get from the decay of organic matter in relatively warm conditions. The Arabs referred to it as Chinese snow.
Right. So China was just a good place at the time, like it had the right climate for saltpeter to occur like that.
Mm-hmm. There's a lot of things that come together, but certainly the availability of the right climate to get it is certainly important.
Can I start assembling it in the right proportions?
Certainly. Well, roughly you want to put in about 50% of our saltpeter.
For every, what, one of those?
Yeah, that's equal amounts of the powdered sulphur that we've got and the powdered charcoal.
What were they trying to make at this point?
This is a mixture for parceling up and throwing basically into an enemy city using a catapult like this. This thing here is called a Gunpowder, which means a fire catapult.
Now, from my knowledge of chemistry, saltpeter is what they call potassium nitrate.
That's right.
Yeah. And that's got kind of oxygen bound up with nitrogen inside it.
If we warm it up, it'll let the oxygen loose, and then that will aid the burning of the other ingredients. The sulphur basically helps everything to happen at a rather lower temperature before, and ultimately, of course, the carbon is the main source of the stuff that burns. There we go, that's good.
Look at that.
Take the flame away now, see it go in the zone. That's very nice.
That's fabulous.
I'd call that an effective incendiary, wouldn't you?
Yeah, I can imagine once you get a bucket load of that landing in your camp.
It's discouraging, isn't it? It makes you wish you hadn't come.
Yes. The black powder that the Chinese military were using in 1044 had got grains of different chemicals close enough to react together and produce lots of heat and gases. In the open air, there's plenty of room for the gases to expand, so there was no sudden explosion, but the basic chemistry of gunpowder was there. However, an even older Chinese book suggests that the very first chemical explosive in the world had been developed 200 years before this.
A book with the lovely title, Classified Essentials of the Mysterious Way of the Origin of All Things, which happens to contain a few recipes listed as, don't try this at home if you are an alchemist. And amongst that is a recipe which I think we ought to try.
I'm game.
You have some saltpeter, you have some sulphur, those 2 ingredients. The carbon comes in the form of honey.
Okay. And what kind of quantities do you reckon?
I would say most of that jar would get us something interesting happening if we got about the same quantity of the other 2 ingredients, the saltpeter and the sulphur, that should go nicely.
Why did they ever think of mixing these things together at this point?
The idea is to try to subdue the fiery properties of the sulphur and of the saltpeter so that they will be suitable for taking as a medicine, hopefully an elixir of life.
Oh, I see. So, ironically, in trying to find a means to eternal life, the Chinese alchemists found a substance that could kill. I've never done any alchemy before. This is my first venture into the world of alchemy.
If you make a success of this, it's a new career, really, isn't it?
Potentially lucrative, I think.
Yes, indeed, indeed. Now, that looks pretty well stirred to me. I would think now if you start cooking that, that will finish the mixing.
Despite being earlier than the incendiary powder of 1044, the chemistry of this mixture has the potential to be more explosive. So, because of the water in the honey, that is dissolving the saltpeter,
yes,
and then allowing that to carefully coat all the bits of
all
sulphur.
the particles of carbon and sulphur will now be very, very close to molecules of saltpeter, which, when they get hot enough, will start releasing their oxygen just right up close to them.
I think that's going to go in a sec.
There's little puffs there, exciting little puffs, I say. We slightly move ourselves out of the immediate line of that, that's it.
Whoa! Okay. Wow.
That was quite striking.
Wow.
Yes. Well, as the Chinese alchemist said, don't try this at home.
So, incendiary mixtures were being explored by the Chinese alchemists as early as the mid-9th century. From the 12th century, as China was swept by waves of war with neighbouring peoples, they started to use their fast-burning powder in a new way. No longer just an incendiary, it became an explosive propellant for projectiles. The Chinese gave their new weapons names like the fast-as-heaven enemy-exterminating yin-yang shovel, the scary, ingenious, mobile, ever-victorious poison fire rack, and my personal favourite, the orifices-penetrating flying sand magic mist tube. In all of them, they put the powder in a tightly confined space, and this fundamentally altered the way it behaved. It was the discovery that would change warfare forever. Confining gunpowder changes the speed of the reaction. It goes from something that just burns into something that really explodes. Gunpowder doesn't need air in order to burn. It gets all the oxygen required from the crystals of saltpeter, potassium nitrate, that are in there, which means it'll still burn in a confined space. And putting it in a confined space increases the rate of reaction. Drop it in here. So I'm going to wrap it up. When it's confined like this, all those grains, the carbon, the sulphur and the potassium nitrate, are all physically much closer together, which means the reaction can happen more quickly. And as the reaction happens more quickly, more heat's created, making the reaction go even faster, and it's a runaway process. Right. With gas being produced so quickly and heat making it expand, there's the potential for explosive force, if I can channel it like the Chinese did. This is my first attempt at a cannon. I've decided to build it out of clear acrylic so that we get to see what happens inside a cannon. Now, I'll drop that on there. Oh, it fits in nicely. My cannonball. So there it is. There's going to be an explosion in there. That explosion will produce hot, expanding gas. There will be a big pressure rise in that part of the chamber. That pressure will exert a force all around the container, but these three sides should stay where they are. This fourth side here, where the tennis ball is, won't stay where it is, and that tennis ball will leave at an undetermined speed that I suspect will be pretty quick. Let's find out. Yeah, that worked like a cannon should work. Wow. You can see how the gunpowder produces hot gases at just the right rate to push the ball out. This technology quickly spread west, through the Middle East, and by the 14th century, the Europeans had rockets and guns too.